A tanker truck carrying 30,000 liters of jet fuel is barreling down a highway at 90 kilometers per hour. The driver hits a pothole. The fuel sloshes hard to the left, and for a fraction of a second, the center of gravity of that entire rolling machine shifts sideways. 30,000 liters is not a measurement you can feel intuitively, so let me give you something better. That is roughly the volume of a small swimming pool, sloshing inside a metal tube on 18 wheels, at highway speed. The engineers who designed that truck knew exactly what would happen in that moment. And the shape of the tank is the reason the truck did not tip over. So why is every tanker truck in the world round? Most people, if they think about it at all, assume the shape is about looks, or maybe manufacturing tradition, or some vague sense that round things roll better. And that logic has a surface appeal. Cylinders are clean, they are aerodynamic, they seem like the natural shape for holding a liquid. Some people who think a bit harder will say it is about pressure containment, because they have seen round pressure vessels before and made the connection. That answer is closer, but it still misses the thing that actually matters when you are hauling a liquid cargo down a mountain road at full load. The real reason has nothing to do with aerodynamics and only partially to do with pressure. Here is the number that should stop you cold. The internal pressure stress in a cylindrical tank wall is exactly half the stress that would exist in a flat wall of the same material, same thickness, holding the same contents. Half. That means for every flat-walled tank design an engineer might dream up, a round one carries the same load with walls that can be built at half the strength, which translates directly into half the weight of the structural material. On a vehicle where every kilogram of empty weight is a kilogram that cannot become payload, that difference is worth as much as fitting an extra small car worth of fuel on every single trip for the entire lifespan of the truck. This is what nobody tells you. The cylinder is not primarily a shape chosen for fuel. It is a shape chosen for stress. When engineers talk about tanks, they talk about something called hoop stress, which is the way tension distributes itself around the circumference of a container when the contents push outward. In a flat-walled box, the pressure concentrates viciously at the corners and edges. The geometry forces the wall to resist the load by bending, and bending is one of the most structurally expensive things a material can do. A flat wall under internal pressure wants to bow outward, and fighting that impulse requires enormous thickness or elaborate internal bracing. But when you curve the wall into a circle, something elegant happens. The load stops being a bending problem and becomes a tension problem. Every point on the cylinder wall pulls against every other point in a pure, even, circumferential tension, the same way a rubber band resists stretching uniformly around its entire loop. There are no corners where stress can pile up and find a weak point, as the load distributes itself so evenly that the whole structure becomes dramatically more efficient than anything with straight sides and sharp angles could ever be. Now layer on top of that the liquid dynamics problem, because here is where road engineering meets physics in a way that has actually killed people. A liquid cargo is not passive. When a tanker brakes hard, all that fluid wants to keep moving forward. When it turns, the fluid wants to keep going straight. The sloshing of liquid inside a partially filled tank creates what engineers call a free surface effect, where the moving fluid shifts the vehicle's center of gravity in real time, independently of what the driver is doing with the steering wheel. A square or rectangular tank makes this dramatically worse. So because liquid in a box can surge from one flat wall to another and hit with nearly all its kinetic energy delivered at once, like a wave hitting a vertical cliff. A round tank has no flat walls for the wave to slam into. The curved surface redirects the energy of the sloshing fluid back into the body of the liquid itself, dampening the surge rather than amplifying it. The physics is similar to why oval racetrack curves have banked walls instead of flat ones. The angle matters, and a continuous curve means continuous redirection of force rather than sudden collision. The origin of this design is not a single inventor in a garage. It is a consequence of industrial disasters. In the early 20th century, as petroleum distribution scaled up and road transport began replacing rail for shorter hauls, engineers were building tank trailers with whatever shapes were cheapest to fabricate, which meant flat-sided rectangular boxes. The failures were catastrophic and instructive. Tanks cracked at their corners under vibration. They failed under the internal pressure of fuel expanding in summer heat. And critically, early accidents involving liquid cargo revealed that a partially filled rectangular tank on a tipping vehicle behaved almost explosively, with the sloshing fluid providing the last increment of force needed to complete a rollover. The railroad industry had already learned most of these lessons with tank cars, and the standards that emerged from decades of rail freight failures were eventually adapted for road tankers. The round cross-section was not a clever idea someone had. It was the survivor of a long process of elimination, where every other shape had already demonstrated how it killed people. Here is where the pleasant recognition lands. The same principle is working silently in a propane tank sitting next to a barbecue grill. Round, because the pressurized gas inside would split a flat-walled container at the seams. It is in every fire extinguisher you have walked past without thinking about. Cylindrical, because the compressed nitrogen inside exerts hundreds of pounds per square inch and cannot be argued with by a flat wall. It is in the water heater in your basement, round for the same structural reasons, even though hot water pressure is far more modest. It is in the steel pipes running under every street in your city, tubes carrying water at pressure, because a tube distributes that pressure evenly around its circumference with no point of failure. And it is in every carbonated drink can, which is technically a thin-walled pressure vessel operating at around 90 pounds per square inch, and which fails at the top and bottom seams long before the cylindrical sides, because those flat end caps are the structural weak points the engineers had to reinforce. It is in submarine hulls, scaled up to resist not internal pressure, but external pressure, where ocean depth tries to crush the vessel inward and the cylinder resists by the same geometric logic in reverse. The round cross-section is not an industrial aesthetic preference. It is the universe's preferred shape for anything that has to hold pressure without breaking. The honest limitation of this design is worth naming directly. A cylindrical tank is a terrible use of the rectangular space inside a truck trailer, and the corners above and below the tank cylinder are dead space, air, wasted volume. A rectangular tank could carry more liquid in the same overall envelope of the trailer dimensions. The reason engineers accept this trade is that the weight saving from thinner walls and the safety improvement from better liquid dynamics outweigh the lost volume by a significant enough margin that the round shape wins on every economic metric that matters. But the next time you see a tanker truck and notice those curved skirts on the sides, those fairings that fill in some of the wasted corner space, you are looking at engineers trying to recover a fraction of that aerodynamic loss while keeping the structural advantages of the cylinder underneath. And if you think the physics of tanker trucks is fascinating, wait until you find out why the steel cables holding up suspension bridges are always twisted into spirals instead of running straight.